And I'm going to create the data set here, and I'm importing the data set into the personalize. So you can see the data set types, and I'm going to rename the columns here: user ID, item ID, and timestamp. Okay, and I'm creating a file interactions.csv, and I'm importing the dataset group. So the same thing which which we did using the console. We created the dataset group, right? And here I'm doing the same thing using the Python SDK, Boto 3 SDK. So I created a personalized client and created a runtime, and I created a dataset group, and this is my ARN, and I am importing all the data into this dataset. Okay. So once the dataset is created, like before creating the dataset, I am defining the schema as well. This is my schema. And here I am creating the actual dataset. Before we created the dataset group, here we are creating the dataset. And now we are going to configure the S3 bucket and IAM role. So which we did in the via console, we created a S3 bucket and uploaded the file, right? And we created the IAM role. So the same thing is happening through the code here. Okay, so this is the bucket name which is going to create, and this is how it looks like. And we are uploading the data to S3 bucket. And here we are setting the S3 bucket policy, which we did via console. Similar way, we are doing it via code. And we created a IAM role. Similar way, like how we did via console. And we are creating the interactions, like import the interactions data into the S3 bucket. Okay. So this is the execution result of the actual notebook which I created. So the data set is created here. Now we have created the solutions. So these are the recipes which we selected via console, right? So we are listing the recipes and we are selecting the AWS personalized ranking recipe here, and we are creating the solution. Okay. And after the solution is created, we can actually do a campaign and see the results. So here we created the campaign. Okay. So when you are actually, instead of using the console, from here we are seeing the campaign data is going to look like this. And when you actually ask for artist ID 987, that's valid data. This is how it looks like. If you ask for a invalid ID, this is how it says, like error obtaining the artist. And if you give a really bad value, this is how it is going to look like. So this is the artist ID, weight, and the user ID. So when you give a artist ID, this is how the data is looking, right? So this is a ranking, how the personalized ranking is going to look like based on the ranking data. So this is like after you create this notebook, we can clean up this notebook as well. So in this exercise, we saw how we can do it via console, how easy to do it via console, and how you can use a SageMaker notebook to do this.
Hello, everybody. This is Vikram Anbaragan. I've been with Amazon for over 12 years now, last 5 years with AWS. Over this period, I've launched a number of our language and speech-based ML services, starting with Lex, and then Transcribe, Translate, Comprehend, Poly, and Amazon Kendra. So today, I'm going to be talking about Amazon Kendra, which is our intelligent search service, and how you could use it for all your different use cases. So let's get started. Enterprise search is still a challenge today. And the reasons are that customers see very low accuracy, and it's really complex. Why do they see low accuracy? 80% of the data that they're searching is unstructured. And they're having to use keyword engines to search through this data. What that means is that these engines are not able to understand the meaning of words that are matching, which results in a lot of noise and the customer having to dig through a lot of results that are not relevant for them. On complexity, especially in enterprises, the data is spread between a lot of different silos. So over a period of number of years, customers have invested in various different content management systems, like SharePoint or Google Drive or Confluence, and they would like to search across all these different silos. So setting that up becomes really complex. To solve all these problems, we launched Amazon Kendra, which is a fully managed ML-powered intelligent search service, and customers can get the full power of ML-powered search without any ML expertise. So this is part of our third layer of ML services, where you can just use the service, get all the ML that is built into it without having to invest in a machine learning or data science team yourself. With Kendra, we're reinventing enterprise search. We're focused on 3 big areas. We want to make it easy to find what you're looking for. We want to make it quick to set up. And of course, it needs to be really secure. In terms of making it easy to find what you're looking for, Kendra can support natural language queries. It's built ground up using NLU and machine learning technologies. We've trained Kendra on a broad range of domains to ensure that you get high level of accuracy. And it also has incremental learning, so it's continuously improving over time. To make it quick to set up, we've built a wide variety of native connectors into Kendra, so you can quickly connect to different content systems like SharePoint or Confluence and so on, and start indexing your data and start searching it. And we also have an even wider variety of connectors that are provided by our partners, so you can quickly get started with searching all your different repositories. And of course, in terms of security, we have encryption, both in transit and REST, as well as token-based access control and customer-managed KMS keys. Let's quickly go through each one of these features. Kendra supports natural language queries. What do I mean by this? So you can actually ask Kendra a question just like you would ask another human being. For example, you could say, where is the IT support help desk? And if the answer exists in one of the documents that has been indexed, it will extract that exact answer and provide it to you, like second floor. Kendra also is able to provide a paragraph if the answer is indeed not a single word, but it's part of a paragraph. So for example, what are the less common COVID-19 symptoms would result in a whole paragraph. And it'll also show you the part of the paragraph which contains the answer, as you can see on the screen. It's built ground up using natural language understanding and machine learning. And it consists of 3 different parts. The first is what we call as reading comprehension. Like I was saying, when you ask a natural language query, it's able to give you that exact answer. And we call that capability reading comprehension. It also has FAQ matching. So if you upload a list of curated FAQs into Kendra and your end user asks a question to Kendra, it's able to go and match that query with all the FAQs and find the closest matching FAQ. It's also able to give you a list of results just like any normal search engine. So it'll give you a list of documents and they are ranked based on relevance to your search query using machine learning. Domain expertise. So as many of you know, when you're training machine learning algorithms, the data that is trained on is really important. And if it is seen similar data to your use case, then the chances are that it'll work much more accurately for your use case. So in order to ensure that the starting accuracy is really high for a lot of different use cases, we've trained Kendra on many of the popular domains like IT, financial services, insurance, pharma, industrial, energy, legal, media and entertainment, travel, hospitality, and so on. So for example, if you give Kendra a question, what is the production increase in lithium carbonate, which is a technical word, it is still able to understand it and fetch the exact answer from the corpus that has been indexed. So for example, it says there are 63 kgs of lithium carbonate in a Tesla 70 kilowatt hour battery, and so on. Continuous improvement. So we provide APIs so that you can collect user input on the quality of your results. So if your users like a certain answer, they're able to give a thumbs up. And if they don't like it, they are able to give a thumbs down. And we take that data and then use that to make the search better so that the next time we are able to give more relevant answers. And Kendra is able to use both implicit and explicit feedback. So even if someone doesn't click on the thumbs up or thumbs down, we are able to look at the pattern in which they click on the links and use that data to improve your search results. Connectors are a big part of enterprise search because, like I was saying, the data in an enterprise is spread across so many different repositories. We currently have about 10 native connectors in Kendra, and we'll continue to keep growing that list, and over 40 plus partner developed connectors to services like Box, GitLab, Slack, Atlassian, Jira, and so on. So it makes it really easy for customers to get started by connecting to all their repositories and start searching across them. Saying data is encrypted both in transit and at rest. We have token-based user access control. So when you are indexing the documents, Kendra is able to index all the access control lists, the ACLs, along with the documents. And then at search time, when your search application has authentic to Kendra, we're able to filter search results based on the access of that particular user. And of course, you are able to provide your own KMS keys for encryption so that you can be confident that your data is fully encrypted and nobody else has access to it. To summarize, in a world of unstructured content, we are moving from lexical or keyword-based search to intelligent search, which is searching for information by meaning. And we use natural language understanding and various machine learning models to take advantage of the rich context that is available in unstructured text and give you the most relevant search results. Let's talk a little bit about how customers are using Kendra today. Some of the popular use cases for Kendra are information in highly technical R&D documents. It's a really high value use case for customers like 3M. Minimizing regulatory and compliance risks. So you can enhance your regulatory intelligence, correspondence, and access to really important in industries like financial services to be on top of all the various regulations that are coming out and all the compliance requirements that are out there. Customers are using Kendra to boost contact center efficiency. So you can use Kendra to assist your call center agents to find questions quickly and find the accurate answers in call centers. And you could also connect Kendra to Lex as part of a chatbot application so that customers can ask questions and you're able to look through a large corpus of FAQs or documents and return the exact answer to the customer's query. You're able to enhance customer experiences, whether that is customers looking for products on your website or whether they're looking for a news article on a certain media website. You can also increase employee productivity using Kendra. So whether that is a search through your policies or HR policies or reimbursement policies or whatever your employees are looking for internal to your organization, you're able to provide them those answers accurately and quickly using Kendra. Let's dive into a little bit into the use case for 3M. So 3M is a Minnesota-based multinational corporation that produces much in between. And science is at the heart of everything that they do. Prior experiments that have been done in their area. And all that data is hidden in patent documents and in a large knowledge base. Before Kendra, they used to find it really hard to find that information. But with Kendra, they're able to run natural language queries and quickly find the information that they need. And this is improving and in turn helps them build more innovative products faster and helps them meet their customers' needs. Another example is Baker Tilly Digital. They are a leading advisory, tax, and assurance firm, and they're dedicated to building long-lasting relationships with their customers and helping them with their various use cases and creating new opportunities. They told us that by implementing Kendra, they were able to surface relevant information 10 times faster when compared to SharePoint full text search. Imagine the increase in productivity that they got by implementing Kendra. So for example, their product managers are able to ask questions like, what parts are made of titanium? And they're able to quickly get answers with a list of relevant product manuals, technical bulletins, service alerts, and patent registrations. Magellan RX is using Kendra to boost the productivity of their contact center agents. And they chose Kendra because their agents are now able to ask natural language questions and get their answers quickly, rather than having to search through multiple systems to find the right answer. And by implementing Kendra, they were able to save about 9 to 15 seconds on every call. And they do about 2.2 million calls per calendar year. So that's more than 4,000 hours of time that they have saved. Another very cool use case for Kendra was for Wall Street Journal. And as you guys know, Wall Street Journal is a household name delivering reporting and access to information for their customers. And they built this Wall Street Journal Talk 2020 tool that allows anyone to ask a question in natural language about what each candidate said about a certain topic of their interest, which could be economy or healthcare or COVID, and then get the exact quotes from that particular candidate. And this was a really successful launch in the run-up to the election, and they were very happy with the performance of Kendra. Another use case for Kendra was CityBot. So CityBot is a citizen engagement service for local governments, and they deployed Amazon Kendra and Amazon Lex to lower call abandonment rates and reduce wait times as call volume shot up significantly during COVID, at a time that was critical for cities to better serve their residents. And they were able to see about 90% reduction in wait times. So how do you get started? We have solution architects that can help you. You can contact our ML Solutions Lab, which will help you get started with proof of concepts. We have a wide partner network that can also help you in doing your TCO analysis, as well as building your search application. And we have a number of tutorials and webinars and blogs also available on our website if you want to get started by yourself. Thank you all.
So for this demo, I wanted to pick a data source that would allow us to compare the traditional search experience on a website with the Kendra experience. So our data set is going to be from our own retail website, amazon.com/help, which provides a search interface for retail customers to search for information related to their Amazon Prime services, Kindle books, Echo devices, and other Amazon products and services. So before we jump into searching what it looks like and how easy it is to get your content into Kendra, we're going to look at setting up two popular data sources, S3 and Salesforce. So I've already created my Kendra index, as we saw earlier in that simple configuration screen, and I've called this index Help Pages Index. So let's add our S3 data source. We're going to click on Add Data Source. And here I have my list of connectors that are available to me, and I'm going to pick S3. I'm going to give this a name, my S3 pages. I'm going to skip the description and click Next. Here I can give the S3 connector the bucket where I want to pull the content from. So I'm going to click Browse S3, and it's going to present the buckets I have access to. And I already uploaded the help pages here in this bucket. So I'm just going to select this one and click Choose. The next step is to select the IAM role I want to use for this particular data source, and I've already created one. The last step is to actually set the sync schedule. This is the frequency at which I want the connector to run and keep the repository in sync with the index. Let's keep it at run on demand so I can actually trigger the sync process manually. I'm going to click on Next. And this is the final review and create page. It's just a summary of my settings before I create the data source. All looks good. I just click Create. And there my data source has been created and active. So when I go back to my data sources, I can see that my S3 pages is created, it's active, and it's suggesting here at the top that the next step is really to sync that data source because there's no content in there yet. So when I click on Sync Now, the data source is now syncing and bringing the data in to make it searchable. Once the sync is complete, this status here will change to notify me. So the sync succeeded, and if I want to see the summary, I just click on the data source itself to look at the run sync history. And here it tells me the last run succeeded, the start time, the end time, how many documents were added, how many were deleted, failed, and modified. And since this was the first time I indexed those documents, the only number I'm going to get here is the total number of added documents. Great, so now this content is searchable. Let's add the second data source. Go back to my data sources. Let's add a data source, and we're going to look at Salesforce now. To keep this configuration demo short, I'm just going to show you how to configure the Salesforce connector, but we're not going to index the data. I put all of the help pages in the S3 bucket so that we can jump to the search quickly. So we click on Add a Connector. I'm going to give my Salesforce data source a name. I'm going to call it SF for Salesforce. And then I'm going to skip the description again. Click Next. Here's where you're going to put your Salesforce domain. So let's give it just kendra.salesforce.com. You'll assign an IAM role also for this data source. So let's just give it another role that I've created in the past. Click Next. Here you're going to choose the credentials you want to use to connect to Salesforce. And I've created one in the past, so I'm just going to reuse that one. As I move down the page, I can start choosing now the objects from Salesforce that I want to index. For example, if I want to crawl the attachments, I can select the attachments. And Salesforce has a series of objects that it stores. It has accounts, contracts, leads, documents, opportunities. So you can choose either all of them to index all of them and make them searchable, or just selectively pick them. So let's say I just select account here to make the account searchable. I also have a choice of selecting knowledge articles if I want to index those, chatter feeds, and the last step here is to set the sync run schedule, similarly to the S3 connector, so how often I want the connector to run. Let's just set it to run on demand since we're not going to index any content. I click on Next. So Salesforce in general is a powerful application that's highly customizable by its users. And Kendra Salesforce Connector therefore provides a simple and yet flexible setup to capture our customers' individual needs in Salesforce. So in this particular step, which is optional, Kendra comes pre-configured to keep things simple for the user and provides a default mapping of fields from Salesforce to the Kendra index. So unless you want to customize how you want to bring those fields from Salesforce into Kendra, you don't have to worry about this. Just use the default settings and your data will be ingested. So I'm just going to keep the default settings here and just click Next. This is the last page where I review and create the data source. Just summarizing my settings. All looks good. The schedule is on demand. And I've done no customizations on the fields, so I can just click on Create. And that's how you add data to your index to make it searchable. So let's go to the Search Console now. So let's try our first Kendra searches against these help pages we've indexed here. Let's say I've bought a Kindle book and I just want to return it. So I may want to just type return Kindle book. And I get a response under Kendra's suggested answer that tells me how to return the book. So to return a legible Kindle book, it tells me the process of how to do this. Okay, that's pretty relevant. I get my answer. I can always go to the web page to find out more about that particular process. But let's say I actually bought a hardcover book and I want to return that. And I'm wondering, well, how much will Amazon refund for postage? So I can ask a very simple question. How much Amazon refund postage? And I immediately see my answer here, up to $20, which was extracted from this passage here from a document in the help pages. Now, if we want to compare the experience by doing the same thing on the website, let's copy the question here, go to the website, and this is amazon.com/help. It just takes you to this page, and you can actually type in here the same question. So I get a list of documents back, and they seem relevant. They talk about returns and refunds. So when I click on this, okay, I see a table of contents. I don't see my answer yet, which is the amount I'm looking for. And if I scan through these, I need to click into these documents to figure out where that particular amount may be located. And after clicking through some of these documents, I realized that the answer was actually in the About or Return Policies. And still, I'm in this document and I still have to read it and scan it to find an amount, and finally I find it here. Amazon will automatically refund up to $20, which is the exact same answer we saw earlier with Kendra. The difference is that Kendra brought it up immediately after I clicked on that search button. Let's take another example here. I recently got a rebate offer from Amazon, and I'm wondering, how long does it take to actually process that rebate? We can ask the question, how long to process rebate? And it gives me an exact answer of 12 to 15 weeks. And again, it was extracted from one of those documents in the help pages. I don't have to go through any documents. My answer is here. I'm done. I can go back to what I was doing. Let's say I use the Amazon Prime Rewards card, and I'm wondering about how to redeem my reward points. So I could type in the question right here, redeem reward points. And this is a simple keyword query. So let's see how that goes. So Kendra's suggested answer at the top here is bringing back a passage that explains to me how this works. Points will be removed as a payment method from your order. The reward points to redeem will be deducted from your rewards point balance when your order is placed. Great, so now I know how that works. What if I cancel an order that I placed with my points? And I want to find out, for example, how long does it take to get those rewards point back? So I can type in how long to refund points. And again, it tells me here, within 24 hours. Last question about these points is, I wonder if my points will expire one day. So I can ask the question, do my rewards points expire? And in the answer here, I can see the bolded section that says, points do not expire as long as you are a card holder. That's a pretty clear answer. The passage extracted is spot on. Let's take a final example here where I just bought a product on Amazon and I'm trying to install it or configure it at home and I'm having issues with it. So I need to contact a home repair service and I'm looking for their phone number. So I can type in phone number for home repair service. And Kendra is able to recognize these numbers in the documents and pull them back into your search results. So this wraps up the first demo where we saw Kendra's ability to answer a very wide range of questions, demonstrating its ability to handle customer service and self-serve applications really well.
Which is nothing but the input word, and then you get an enhanced representation of those words in the output. So if you look at it here, we have shown 12 layers because it could be 12 or it could be 24. In the research paper, they tried with many different layers, and there is a BERT base model, there is a BERT large model, but the idea is it has lots of layers. So here we have 12 layers, and each layer comprises of a fully connected layer or feed-forward network and a self-attention layer, which we are not presenting in this slide. The token and the output, you get a special or enhanced version of that particular token. Right, and there is some different set of tokens that BERT uses, and that's why I colored it in blue. That represents that there are some special token like start of the sentence or end of the sentence, or there's a special token for classifier, and we are going to see that in a moment. But the idea is the same. It takes one token and it generates an enhanced version of that token, and when it generates an enhanced version of the token, it takes care of all those tokens in the sentence. So here I have mentioned that as you see, there is a one connection, but actually there is multiple connections. Okay, so the idea is when an enhanced version of this token is getting created by each layer, it takes care of, or it comprises of the encoders or the embedders of all those other words. So the output here, what you see, is an enhanced version of this particular token, but this contains all the information, all the necessary information of this whole sentence. Okay, so here what we see is just one single line, which is kind of a one-to-one connection, but you can imagine that it's actually not one-to-one. I've just removed all those lines to make the diagram a little simple, just to represent that if you have, n number of words in a sentence, the output you will get are exactly same n dimension. So basically, each input will generate one output. Now, as we mentioned that it is a pre-trained model. So what do we mean by pre-training? So the way that BERT works is they try to make a model which can help to understand the language, right? And they can do so. I mean, they did that by solving two problems. And these are the two tasks. One is masked language model, and another is next sentence prediction. So these are the two different tasks the BERT was trained on. Okay, so let's see that what these two tasks mean. So masked language model means given a sentence, okay, it will mask few of the words, and all it has to do is it has to predict that masked word. So now reading sentence A and sentence B. And we are going to, mask few of the words in this sentence. So you see that there are various tokens. So you can think of tokens as, words like token 1, token 2, and token n. Similarly, there are different tokens for sentence B. And what BERT did was it masked few of these words in a sentence, and the task of this model was to predict those masked words. Okay, so this is what we have to generate. We need to generate these masked words. Okay, so this is one task. And the other task was, since it was taking two sentences, and all it has to do is it has to predict that sentence B should be the next sentence to sentence A or not. Right. So basically, it has to predict that the next sentence is actually the next sentence of the previous one or not. So it's kind of a binary classifier that if I give two sentences, the model needs to tell me that the second sentence actually should come after the first sentence or not. And that is why it uses a special token called classifier or CLS. And this gives you a classifier towards the end. And this is the first encoder or not encoder, the first embedder and the token. And you can just simply use this token in a classifier, like let's say a simple soft feed-forward network with a softmax function, and it can tell you that, okay, it can be either 0 or let's say it can be either 1. And 0 means, let's say sentence B is not the sentence which should come after sentence A, or it could be 1, and that means that sentence B should come after sentence A. So basically, there are two tasks that we are accomplishing. One is, given a sentence, we will mask them and mask few of the words, and the model should predict those masked words. That is first. And the second task is, given two sentences, the same two sentences, we have to come up with a prediction that these sentences are, next to each other or not. So these two tasks were taken care during the pre-training phase, and these two were done simultaneously, not one after another. And what happened during this process is the BERT model itself got a very good understanding of the language, right? So now what we can do is we can make use of this BERT model, and we can use some classifier on the very top layer, right, and make use of those enhanced embeddings and solve our problem, like sentiment analysis or grammar check or whatever it is. So the next part is in the fine tuning, and this is where you can make use of BERT, and you can just put your own classifier on the topmost layer, like here. Once we get the enhanced embedders of all these tokens, we can use some classifier on top and solve our problem that we are looking for. For example, let's say we take a problem of question answer pair, where the input will be a question and a paragraph which might contain the answer of that particular question. So all we need to do is, in the input, we will pass the question and the whole paragraph. So these are the two things that we will be passing to the model. And in the output, in this output layer, what we are interested to know is whether this question can be answered, or the answer of this question is there in that paragraph or not. That means you have to come up with some classifier for all the tokens, where each token or the output of that classifier will have let's say, a probability distribution of start and end. Okay, so that means, let's say the paragraph is of 100 words. So each of those 100 token will have a classifier, and it will have a probability that, okay, this is the word where the answer should start, and this is the word where the answer should end. So you know that which word the answer should start and which word the answer should end, right? And we don't have to train it from scratch. All we have to do is we can make use of these pre-trained model, and we can just fine-tune it with our own data set. So this is how the whole thing works, as we have just discussed. For sentiment analysis, we can think of it as we will take this pre-trained model, and this is the model that we can get it from many modules. Like we are going to use transform modules from Hugging Face, and this completely trained, right? So we know the weights of all the matrices that are used within this BERT model. And all we have to do is we have to make use of these classifier or the CLS token towards the end, and we can just discard all the output of all the tokens, because we don't need that. All we need is, given a sentence, we have to come up with a prediction that the sentence is of positive sentiment or a negative sentiment. Like in this example, the sentence that we are feeding is "you are awesome." So this is surely a positive sentiment statement. So what we can do is we can just take care of this particular token, and we can just put a soft we are sure that this token can capture all the information of this whole sentence, because this is how the self-attention works, right? So we have seen that how a token gets an enhanced embedding using all the words in that whole sentence. So similarly, we can also use this for many other tasks, like let's say name entity recognition, where we are going to use the same network, but all that we need to change is the top layer classifier, right? So in this case, we need to make sure that every word will have some classifier, and it could be any function that you would like to use. But all we need to know is if any word or any token is having any entity or not. Like AWS is an organization, so the output of this classifier should give us that information that, okay, this is an organization, or there is a name, or whatever it is. And in this particular problem, we don't care about this classifier, because this is of no use. So to sum it up, we can use a pre-trained BERT model, and we can make use of that by adding our layer on top of it, which we call it as a fine-tuning, and solve our problem. So in this next demo, what we are going to see is we are going to solve a problem of grammar check. So as the name suggests, given a sentence, we need to predict that this sentence is grammatically correct or not. So as we can imagine that this is very much similar to sentiment analysis, and it's a binary classifier that yes, the sentence is grammatically correct, or no, the sentence is not grammatically correct. So all we need to do is we need to take care of this CLS token, and we can make use of this pre-trained model. And what we have to add is we have to add top layer feed-forward network, and we can just use a softmax to get some prediction, right? And CLS is a special token which BERT expects for whenever you feed any sentence or any input, you need to make sure that you add this CLS in the beginning. And there are because BERT is trained with a certain vocabulary, right? And it has a different technique of tokenization, and we need to use that when we put or when we feed that input data. So these are the steps that we need to go over. We need to first build a data set with the label sentence, that sentence which are grammatically correct or sentence which are not grammatically correct. We have to take that data set, and then we need to use a pre-trained model, and we are going to use Hugging Face for that. And we need to convert into all the inputs to the via tokenizer, which which our BERT expects. So we cannot use our own tokenizer. And then we need to train the model and come up with this prediction. So with that, let's go over to the console and go over the code. This is our SageMaker notebook, and I've logged into my account. And if you are new to SageMaker, SageMaker is a service which you can use for building or training and deploying your model. And it has lots of different features and capabilities. And you can also create your own Jupyter Notebook instances, and everything, all the modules like TensorFlow, PyTorch, everything is inbuilt in that, right? So I do have one of the instance ready, and I've just opened it in another console. And this is the code that Jupyter Notebook that we are going to use, which is opened in another tab. Okay, so what we are going to do is first we need to import few of the libraries that we need. Okay, so we are going to use SageMaker SDK, and we are first creating an object for the session, and we can do so by SageMaker.session, and it takes all the information of which region that you are in and what are your credentials and all of that. So this is this takes care of your whole environment where you are now. Now we are going to use this bucket, and this is the prefix that we are using, and this is just to make sure that while the training is going on, we need to provide some path where our data set would be, and after the training we need to have some path where it will save those model artifacts or the model output. And this is the data set that we are using, corpus of linguistic acceptability. So this contains roughly around 11,000 or 10,000 English sentences, which is good enough for us to fine tune. We're just downloading it and unzipping it, and we are saving it under this folder. So if you just look into this data set, how it looks like, we can just use Panda, and we can just see how the data looks like. So this data contains lots of different fields. All we were interested in the labels and the sentences. So that's why we are just having these two parameters or these two features. And if you just have to print those, we can see that there is a sentence and there is a corresponding labels. So 0 means grammatically incorrect and 1 means grammatically correct. So this is our, you can think of it as a X and Y, right? XI and YI. This is the input data, and this is the class label. So this is the same thing that we are printing it in the data frame. So you can, it's of class label 1, but it does have a good amount of data. And now what we have to do is we have to first split the data into train and test. And this is what we are doing here using scikit-learn's train and split functionality. And once we have this, we are just saving this CSV in the form of train.csv and test.csv, and we are uploading it into our S3 bucket. And which bucket it is the same bucket which we defined a while back. So we now know where our data is stored. So if we remind ourselves, this is the first step that we had to do. We need to build the data set, which is done now. And now we have to build the model, or we have to train the model. And the way that we are going to use is, we are going to use the PyTorch implementation for transformers, which is nothing but the Hugging Face library. And we are going to train it not in this Jupyter Notebook, but we are going to use a SageMaker for that. And for this, we have created a script called train and deploy. And we are going to see that, what this script looks like. And we are going to pass this script to the SageMaker, and SageMaker will. Now, if you look at this train and deploy .py file, you will see that we are using this Hugging Face library, because once you install that, you will find this package called transformers, and from there is a class called BERT for sequence classification. So this is a classification problem, right? That whether a sentence is grammatically correct or not. So we can simply use this, this class to create our model. And we are also using bird tokenizer, because this is what the most important thing we have to do before even feed the data to the network, because we need to tokenize all the inputs that we have, or all the sentence, because this is a special type of tokenizer that we need to use for BERT, because this is how BERT was trained or pre-trained when it was trained for those two tasks, right? That is mask. Language mask problem and the next sentence prediction problem. So now if I just scroll down, there is a method for get trained data loader, and this is where we use that tokenizer and we do that encoding, and this is a tokenizer which BERT has. And the important thing here is how we do the training, right? So if you look here, this is the model that we are creating, right? And we are using this BERT for sequence classifier from a pre-trained model, and this is the base model that we are referring to. This is BERT base uncased. So there are different models, there are different base models available. This is a 12-layer BERT model. We also have a 24-layer, and we also have uncased. So cased and uncased means, when we say uncased, in that case, when we have a word with small letter and when we have the same word in capital letter, all will have the same embedding, right? So all both of them will have the same vector. So you can also use a cased model as well. And we are passing the number of labels. So since this is a binary classifier, for us it would be 2, and this is what we are passing here. And there are a few other parameters. We have not talked about it, but we know that in BERT we have encoders, and within that we have self-attention units. And if you say that you need to know those self-attention output in the final layer, you can make it as true, and you can use that for any of your fine tuning. And then there is a simple thing like for any CNN or any deep learning based model, we just load that model into a device of our choice. It could be in CPU or GPU, whatever you feel like. Then we have the optimizer. We are using AdamW optimizer, and we have some learning rate, and these are pretty straightforward, straightforward steps for any deep learning problem. And let's scroll down. So now that we have the script ready, now we have to start the training. And the way that we can start the training is using SageMaker. And what we can do is we can just use SageMaker SDK, and we can import this class called PyTorch. And here you can and you can give an entry point. So this is what this entry point means is this is the script that it should take to start the training. And the way that in SageMaker the training works is you can define the type of instance where your training should happen, and it will just kick off there. And once the training is over, it will just destroy that container, or it will just destroy that infrastructure for you. So the training is not going to happen in this particular thing, that this is the entry point, this is the location or the source directory where the script is there, and there are a few other parameters that we are passing on, like instance count is 2. That means I want this training to happen in in a distributed fashion. So I want this to happen in 2 different containers. And here we are defining what type of instance we want for training, right? So you can define your own instance type here. And once this is all done, we can do estimator.fit. That is, you are just starting the training and you are passing the input training data and the input test data. And once this training is over, what you can do is you can simply use deploy method on this estimator object. So now when you when you define this, when you call this deploy, then also you can say, it can, you get an option to select the instance type where it will be deployed, right? So here I'm saying that deploy in this particular type of instance, right? ML, M4, X large. So you cannot very well, put any instance type of your choice. How it knows that how to load that model and how to deploy. Everything is defined in that. We have a method called model FN. So if you just go up and what it is doing is it is first defining the device, whether it's a CPU or GPU, and then it is loading this from this model dir or model, and give some sentence, and it will give you the prediction. So it's one means it's grammatically correct, and 0 means grammatically incorrect, right? So if you think of it that let's say it was a very, so it's an incomplete sentence, right? So that's why it's predicting as 0. So this is how you can deploy your models. But now if you look at it, when we think about deployment, we just pick this instance, right? And it could be any GPU-based instance or CPU-based instance, and it might be very costly for you, or it may not be always easy to understand what type of instance we should use for deployment. For training, we can understand because we know how much with a fraction of cost. So all you have to do is when you try to deploy, you have to mention the CPU instance as well as the elastic inference based GPU instance. That's all, right? And it can make use of those GPUs when it's now in the tar format into a torch script. So the way that we can do this is we can first download that, and we can extract this, and we are extracting this inside this model directory. And then, so now this all the model artifacts are inside this notebook. So all these are the model artifacts, right? And now we have to convert that into a torch script. And the way that we can convert it using the PERT for sequence classifier from pre-trained. So this is the method that we are going to use, and we are going to say torch script equal to true. Okay, and then we can just say, whether the device is CPU or GPU, whatever it is. And there are a few, configurations we need to do beforehand, because this is how, JIT trace, and we can save this model artifacts into a .pt file, or this is the weight file that we have. And then we can just do the same thing. We can just zip that again into a tar file. And later on, we are going to upload that to S3 and use that for deployment. So now for deployment also, we have a special script called deployed_EI. And this is a little bit different with respect to the train and test or train and deploy.py, which we have used, because here, the way that we are loading this is using torch.jit.load, and we are giving this weight file. Whereas if you look back up, when we deploy this model using SageMaker instance, regular instance, we load it like this, right? From from pre-trained, and then we gave this model dir, and we used this BERT for sequence classifier, right? But now we are using, one second. Yeah, we are using torch.jet load. Okay, so we are just loading that model which we have uploaded in the S3. So once this is done, we can deploy it. And I'm sorry about that. So now we can deploy this model using elastic inference, right? And we will come back to this costing in a bit. But the way that you can deploy is you need to mention what should be the instance type and what should be the accelerator type. So this is the EI instance type, and this is the CPU instance. And we can just mention the tar file. And we have to first upload that. This is what we are doing in S3. We are uploading this, and we are simply using torch model class, and we are mentioning this model data that is this S3 bucket location, exact location, and we are providing this deploy _ EI script, and there are other things like what should be the version of Python and so on. And once that is done, we can deploy this using elastic inference. And here we have to mention both the types of instances. One is the instance type. That's all. And then you can just deploy it, and you can do the inference just like before. Now, the last thing is I want to touch upon on the cost part, how elastic inference can give you a better ROI. If you look at it, these are regular instances which you can use for deployment, and it costs pretty high, right? And you may not use it. But if you look at the elastic inference, these are in cents, right? So if you combine the costing of compute optimized and inference acceleration, it would be very, very less with respect to any particular type of instance which has GPUs, right? So this is where we always recommend to make use of elastic inference. So towards the end, once you are done with that, if you want to delete your endpoint, you can just use the delete endpoint method. Right, so that's about it. So let me go back to the slides. So thank you so much for your time. I hope that you got some idea about NLP and how you can deploy any NLP-based model using BERT, using Amazon SageMaker and Elastic Inference for your inference, and make use of these capability that we have in SageMaker. I know there are a lot of content here, and I'm going to share you a few of the blog posts which are in line